Let me illustrate the point that I made earlier about the third step from this procedure of solving a separable differential equation being possibly the most troublesome. As an illustration, let us consider this equation that we're supposed to solve. And so we have dy over dx equals 6x squared over 2y plus cosine y. So this clearly is a separable equation. Now we have in the right-hand side product of, or a ratio rather, ratio of a term that only depends on x and a term that only depends on y. You can go ahead and separate variables right away. This gives 2y plus cosine y dy equals 6x squared dx. Then we'll integrate both sides, which results in the following. We'll get the integral of this expression here equals to this expression here. As a result, we'll get y squared plus sine y equals 2x cubed plus a constant. Now, if we were to try and fulfill the third step of our strategy, which is solve for y, so this unfortunately is not going to be possible in terms of elementary functions. So we won't be able to express y easily in a closed form from this relation. What we can do though, so this unfortunately is impossible. Now what we can in fact do is to solve for x. So if we are willing to take the answer not as a y being a function of x, but as x being a function of y, then we can in fact solve this quality here. And so we'll obtain that x cubed equals 1/2 of y squared plus sine y plus a constant. So in principle, I should be adding minus c over 2 in the right-hand side, but if I reassign minus c over 2 to a new constant, I can just call it c1. And so this gives as a result that x equals cubic root of 1/2 y squared plus sine y plus a constant. So this is the family of functions solving this differential equation. We do not have an initial condition, and so as a result, our answer consists of an entire family of functions. So as you can see, in some cases, the dependence of y on x can be rather involved or too involved to be expressed in an explicit form. So instead, say, if you were given such a question, then you should leave your answer in this form. Alternatively, if the problem asks to express x as a function of y, you can indeed go ahead and do the computation that we just did. But if not, it's okay to leave the answer in this form here. So this could be the answer to this question, because y cannot be expressed explicitly through x. Now, in most questions that you will have on quizzes and tests, you will be said directly to express y as a function of x, and that means in these questions it will not be too difficult to do that. So you should always try to derive your answer as y equals a function of x. So that is because the questions that you will be given will be free of the issues like this one.